Temperature conversion. The degrees Fahrenheit is used to record surface temperature measurements by meteorologists in the United States. However, since most of the rest of the world uses degrees Celsius, it is important to be able to convert from units of degrees Fahrenheit to degrees Celsius. Kelvin is another unit of temperature that is very handy for many scientific calculations since it begins at absolute zero, meaning it has no negative numbers. It is important to note that Celsius and Fahrenheit are expressed in degrees, while Kelvin is not. The following formulas will allow you to compute temperatures from one unit to another. Use them whenever necessary. How was pH derived? pH is defined as the unit of measure which describes the degree of acidity or alkalinity of a solution. It is measured on a scale of 0 to 14. The term pH is derived from letter P, the mathematical symbol for negative logarithm, and H, the chemical symbol for hydrogen. The formal definition of pH is the negative logarithm of hydrogen ion activity. Originally, there was a negative sign right before the letter H. This created confusion, or did not look good, when used to start a sentence, so the negative sign was replaced with the letter P. Hence, the formula pH equals negative log of hydrogen ion activity. Density and specific gravity. Density is defined as the mass of a specific volume of an object, while specific gravity is defined as the ratio of the density of the solid part of a material to the density of water at 20 degrees Celsius. With the given sample, you will notice that the density of the object and its specific gravity are the same, except that the specific gravity is unitless. This is true if the temperature was the same for both density and specific gravity measurements. Although there is a difference between specific gravity and density, for the most part, the values are similar enough to be used interchangeably. Expressing concentrations. In physical pharmacy, concentrations are expressed in many ways. Examples of these concentrations are milliequivalent, percentage, osmolality, percent weight by weight, weight by volume, volume by volume, and many others. But for this lesson, we will focus only on 4 common concentration expressions. These include molarity, molality, normality, and mole fraction. Molarity is defined as that number of moles of solute present in 1 liter of the solution. Molality, meanwhile, is the number of moles of solute present per 1 kilogram of solvent. Note the difference between the two. Normality, on the other hand, is defined as the number of equivalents of solute in 1 liter of solution. Mole fraction is defined as the moles of the target substance present divided by the moles of the total substance. You are expected to have a good understanding of what percentage strength is from your previous course. You will need your periodic table for this lesson. In the materials you can use for this unit of your classroom, you will find a PDF copy of the examples. Please study them well. If you have any questions regarding the material, please don't hesitate to ask your instructor.